Hi everyone, in this video we are going to start our final project. For our final project we are going to create a basic voting app where we can vote, approve, reject or pass for a proposal. We are going to store these proposals so that we can iterate over them. So let's get started with our basic structure setup. As you can see, I created some imports here and also I created our memory like we did in our previous chapter. And we also have the max value size. So this is just a basic setup that we are going to use in many cases. So I just went over it and created for us so that we can start our coding right away. For our project, we are going to have two structs. The first struct is going to have our data for the proposal, and the second struct will be provided for our functions so that we can create our proposals and edit them. We don't need all the fields for our first struct. We have a separate struct just for function parameters. So I'm going to start my struct with our derive. Don't forget, since we are going to need these to implement in the Candid file, we are going to say these are Candid type. And by saying these are Candid type, what I mean by these are our structs. We are saying that we are going to convert this to a version that can be used in the Candid file. Also, we are going to import this serialized. Okay. Our struct's name will be proposal. And we are going to have a couple of fields. First, we will have our description. And it will be a string. Next, we have approve, which is U32. This approve means the number of approves we have in our proposal. Instead of saying number of approves or number of rejects every time, I'm just saying approve. But if we have 5 as a value in the approve, it means that we got approved 5 times. So we are just holding these numbers as the counters. Next, we are going to have reject, which is also going to be U32. And finally, we have pass. So these will be the 3 options that we are going to have. And then we are going to have more data about our proposal. First, we have is active. We have this is active because we may have some proposals, but since their time has passed or the creator just stopped it, we cannot vote on it anymore. So to hold this value to decide when we can vote or not, we are going to have this is active. And it's going to be a type of Boolean. We are going to have different principles stored here, and these are the people who voted already for this proposal so that one person can just vote one time. And we will be saying a vector, and it will be principal from the Candid type. And finally, we have the owner, and this will be the owner of this proposal. Again, this will be principal. All right, this will be our basic structure. We have an error here. Let's check it out. All right, in our corgo.toml file, we need to add this sarde so that it can work with it. Now everything looks okay. And we are going to create our second struct, which will be create proposal, and we are going to use this as an input for our edit and create proposal functions. Again, I'm going to say derive Candid type and deserialize. And inside this struct, we will have the description, which will be type of string, and we are going to have is active. We just need 2 different fields here because we are going to initialize approve, reject, pass with zeros. And also when we want to edit, we cannot edit approve, then it would be not reliable. And also the people who have voted cannot be changed, or we are not going to initialize this with something. So we are not going to touch these fields, and also the owner will come from the message. We are not going to type who is the owner. So we don't need to give these fields as a parameter. We just need to give description and is active. Now that we have created our structs, let's implement our traits for these structs like we did before. First, we are going to say implement storable for proposal. And we are going to say 2 bytes to serialize it. And inside this, we are going to say cow owned encode. And inside this, we are going to provide self.unwrap. If you cannot do this by just memory, don't worry about it. It's going to take some time, but as you can see, we did this before. and it's a pretty straightforward process. So after a while, you get used to it. As you can see, we have an error here, and the error says that not all trait items implemented missing from bytes. We created the 2 bytes, but we also need to create from bytes because that's what we need for the storable trait. Now let's say from bytes, and inside this from bytes, we are going to decode what we have, and we will say bytes dot as reference, and we are going to have self as a second parameter, and finally unwrap. Again, at this point, you don't have to know what every function and every bit does in this trait implementation, but what we need to know is that with this 2 bytes function, we are actually serializing our data to bytes to store on the stable memory, and then we are deserializing back so that we can have our variable back. As you can see here, we have a return type as self because we are decoding and getting back the data. This is necessary for our serialization and deserialization process for our upgrades, and that's why we also said deserialize here. Now we are going to implement bounded storable for proposal. We are going to say to our construct that how we are going to bound this structure that we are creating. We will say the max size will be max value size value that we have here, and also we are going to say is fixed size, and then we will say false because it can grow and shrink, and that's why we are creating this structure. Now we have our 2 structs that we are going to use. We said that we are going to use this for our main structure for our state, and we also have a separate one so that we can use with our functions as parameter. And then we implemented storable so that we can serialize and deserialize our proposal struct here. And then we implemented this bounded storable so that computer knows what are the limits of our structure. Now the last thing that I want to do for our state management part of this contract, we are going to create our thread local, and we are going to implement our memory. I will say thread local here, and inside this we are going to create our memory manager like we did before. If you remember, we have just one memory that we can work with here, but we want to have a structure that can work with different kind of memories. We need to have multiple memories. So instead of having this physically, we are creating this structure virtually. And for this, we are using memory manager. And since we are going to have 256 virtual places that we can use as memory locations, we are going to say this one is for the 0 index, this one is for the first index. Using the structure like this, we can have multiple memory locations. I'm going to create my memory manager by saying memory manager, and its type is going to be refcell because we want to borrow what we are going to create as mutable or immutable, and we will say memory manager, and inside the memory manager we will have default memory implementation. So this will be the type that is going to return to us, and what we are going to say here is that refcell new memory manager, and we are initializing our memory manager. We are initializing it with default memory implementation, and let's call the function default. Alright, again, I know it looks like too much, but once you know what you want to do and once you know how it works, after a couple of implementations, it's going to feel much more natural than it's feeling right now. Again, we are creating this memory manager using refcell, and we are calling new function from this refcell. We are going to do this for our other maps that we are going to use. And we are initializing our memory manager with this default memory implementation. Now let's create a proposal map that is going to hold our proposals. For that, I'm going to say static proposal map, and its type is going to be refcell stable B3 map. We are going to have U64 as the key, but we are going to have proposals as the value, and we are going to use our memory. Again, we will say refcell, and we are going to call the new function, and inside this new function we are going to say stable B3 map init. As you can see, we are doing a very similar thing like we did before. We are creating this ref cell with the new function, and we are initializing our stable B3 map. Before we were initializing our memory manager, so we were saying memory manager init. Now, since we are initializing our bstable3 map, we are saying bstable3 map init. So even though there are differences, you can see that the basic idea and structure is the same. And inside this init, we are going to say, let's make it like this, memory manager dot with, because we want to create our memory inside this memory manager so that we can have multiple memory locations if we need them. And let's say m here. So we are going to borrow this m, and we are going to say get memory id new 0. So it's exactly how we did on the last chapter. Alright, so this will be the structure for our smart contract. So let's review what we did in this lesson. We created two different structs, one to store our data and one to use as parameter. Then we said that, okay, we created this struct, but this struct needs to implement some traits so that we can deserialize and serialize it. So for this process, we said we are going to implement this storable trait. And inside this trait, we had 2 bytes and from bytes functions. And if you forget one, as we saw earlier, Rust is going to complain. You cannot just miss it or skip it. You will have to fix it, and it's going to tell you that one function is missing. And then we said, okay, now we can serialize and deserialize it. But what are the limits? The computer doesn't know it. For that, we created our limits using the bounded storable trait. And inside this trait, we have our max size and isFix size. For our max size, we use our max value size that we defined in the beginning of the contract. Next, after everything is ready, we said that we are going to actually create our memory location so we can use this structure that we created. For that, we said first we need to create this memory manager so that we can have multiple virtual memories. And after we created this memory manager, we created our proposal map, and we use this memory manager to handle our memory locations. And we use the first memory location with the index 0 for this. Alright, thank you for watching this video. Again, as you can see, we are doing a similar process like we did before, so there is nothing to worry about. And in the next lesson, we are going to start implementing our functions so that we can see how our contract is going to work. Thank you very much for this video, and I will see you on the next one. Hi. In our last video, we created our state and we created our thread local so that we can work with our state. And in this video, we are going to create our first function. We are going to start with the query functions since they will be pretty straightforward. We are going to say IC CDK, and from IC CDK, we are going to use query. And the first function we will have is get proposal. With this function, we are going to get a certain proposal. I will say key use 64 here, and we are going to return an option. And inside this option, we will have our proposal. So if you remember from the last chapter, we are going to use .with function. Since we want to work with proposal map, we are going to say proposal map .with, and inside this, we will have our p. Now we got used to it, and we are going to say I want to borrow this p. It doesn't have to be mutable because we are just retrieving data, not changing anything in the state. And then we are going to say I want to get the one with the key. So here we have the key as the parameter, and we are getting the value from our stable B3 map based on this key. Alright, that will be our first query function, and our next query function will be something similar. Again, we are going to say IC CDK, and we are going to use query, and we are going to say get proposal count this time so that we would know how many proposals we have. We will return use 64 in this case. I'm going to say again proposal.with because we want to work with the proposal, and we said that using .with function with this proposal map, actually we are creating an encapsulated safe environment that we can work with. And inside this, we are going to have a closure. I generally use p, but you can use whatever letter you want. And again, I will say p.borrow. And in this case, instead of get, I'm going to use .length function because I want to return the length. I'm not retrieving any data. and this will be our second query function. Now that we have our query functions, let's create our first update function. And as you would guess it, I'm going to use IC CDK and update. Our first update function will be create proposal. With this function, we are going to create a proposal. So creating a proposal in our case is basically creating the struct using the given parameters, and we are going to fill the rest of the struct based on how we want to initialize our proposal, and then we are going to insert this struct to our stable tree map. And as a parameter, we are going to have our key, which is going to be U64, and we will have our proposal, which is type of create proposal, and that's why we created a second struct. And we are going to return an option, and inside this option we are going to have our proposal. After we insert our proposal to our map, then the data that is going to return to us is the one that was there before we inserted it, and if there was none, then we are going to have the null. And since we don't work with null in Rust, that's why we have this option. First, inside this function, let's create our proposal. I'm going to say let's value, and it's going to be type proposal, and let's create our proposal. So the description is going to be proposal.description. If you remember, in this create proposal, we have the description. So we are going to take the description and is active from this proposal. Then we will have approve, which is going to be 0. We will have our reject, which is also going to be 0, like the pass here. Next, we will have our is active, and as we talked about, we are going to get it from the proposal parameter. And we have voted, and we are going to initialize it with an empty vector. And finally, we will have the owner, and again, we are not typing owner. We are getting the owner from the address from the principal that called this function. To have it, we are going to say IC CDK, and we are going to use the caller function. And this IC CDK caller function is going to provide us the principal that called this function. Alright, now we have our value that we are going to insert to our stable B3 map. Now it's time to insert it. I'm going to say proposal.map.width, and again we will have our p here, and we are going to say p.borrow mute this time because we want to alter the data, and we are going to say insert, and we are going to have the key value pair, and they will come from these parameters, this key and this value. So once we say a key value, then we are going to be fine because this is going to be our key and this is going to be our value that we created up here. All right. Now we also created our first update function, and in our next video we are going to continue with our functions for the smart contract. Thank you very much for listening to me on this video, and I will see you on the next one. Hi everyone. In our last video, we started creating some functions, and we started with the query functions, and we also created an update function to create a proposal. And in this lesson, we are going to move on with our functions. Before moving forward, we are going to implement two enumerations so that we can handle the errors for the following functions. And also we are going to have an enumeration to make a choice. It's going to be either approve, pass, or reject. To create our enums, first I will start with the choice. This enum is going to have three fields: approve, reject, and pass. And also we are going to say drive, and we will say Candid type and deserialize. So again, this will be our enum for the choice. We are going to have three different fields: approve, reject, pass. Depending on which field we have chosen in our input, we are going to update our proposal accordingly. Next enumeration that we are going to have is a vote error. Here we are going to have our error type so that we can return with the functions, which is going to be much easier for later, for real projects that you are going to build, so that you would know how to handle your errors. For that, I'm going to say again derive, Candid type, and next we are going to say enum vote error. Alright, inside this enum we are going to have already voted, proposal is not active, invalid choice, no such proposal, access rejected. This one will be for principals addresses trying to access or use a function which they cannot use because they are not the owner of the proposal, like edit proposal function. And finally, we are going to have a more generic error saying update error, and we are going to use this in multiple cases. And these cases will be if you don't know what went wrong, but something went wrong. Actually, it will be our 404. And goes this. Now we have our choice and we have our vote error so that we can move on with our function. First function we are going to create will be edit proposal function, and the owner of the proposal will be able to edit our proposal using this function. So let's say IC CDK, and we are going to say update since we are going to alter the state. Then we are going to say function edit proposal, and we are going to have our key as U64 because that's how we are going to retrieve data from our map. Next, we will have our proposal, and this will be the type of create proposal which we created just for these occasions. And then we are going to have our result, and as we said that we may return an error for the first variant, we are going to leave it empty for the OK situation, and for the errors we are going to say what error. And inside this function we are going to say proposal map.width. I think we are used to this at this point. And inside this function we will have our p, and we are going to use curly brackets here because it's going to be a longer ones than we did before. Alright, so the first thing that we are going to do is we are going to retrieve the proposal with the given key. For that I'm going to create a variable called alt proposal, and I'm going to say option because what we are going to have is an option, and then we are going to check this option because if we have some problem we want to return what the problem is. And this will be equal to p.borrow.get, and that's like the ones that we did before, and key. Again, this will give us an option, and we are going to open up this option to see if we had the right value. First, let's say alt proposal, and this will be the type of proposal. Now, we are going to say match alt proposal option, and we will say if we have some value in it, then our alt proposal will be equal to this value. But if we got none, then we are going to return an error, and this error will be a what error saying that no such proposal. Let's see what's wrong. Alright, since we haven't completed our function, it's complaining about our return type. Alright, so we created an alt proposal, not the option one, and we haven't used this yet. Then using the match, we looked at our alt proposal option, and if we had some value in it, then our alt proposal is now the proposal. But if we don't have any value in it, we got none, then what we are going to have is a vote error, and we are going to return no such proposal. After this point, what we are expecting is that we already have our proposal so that we can work with it. Next, we are going to check if the caller is the owner. For that, I'm going to say if IC CDK caller, and if you remember, that's the principal that's calling this function, not equal to alt proposal dot owner. So in this situation, the caller of this function is not equal to the owner of our proposal, so that we are going to block this user by editing our proposal, because imagine that you create the proposal and anybody can edit it, which wouldn't make much sense. So if this is the situation, we are going to say return error, and inside this error we are going to say access rejected. Let's check our error. Again, it's about our return type. We are going to solve this in a bit. Now that we checked that if we got the proposal and if the caller of this function is the owner of the proposal, and if our function is okay till this point, we are going to move on by implementing or editing our proposal. For that, I'm going to say let value, which is going to be type of proposal, equals to proposal, and it's like the time that we created proposal. Up here we are going to use the same ideology. I'm going to say description will be proposal.description. Approve is going to be alt proposal.approve, because we are actually transferring these values. Then we are going to have reject, and we will say alt proposal.reject. For the pass, it will be the same thing. Old proposal.pass is active will be old proposal.is active, and this way we are actually conserving our values from the old proposal to the new one. After the is active, we have voted, and for that we are going to say old proposal.voted. And finally, we have the owner, which is going to be the caller of this function. So we are not actually changing the owner. And again, we should actually say this is proposal.isActive. Now that we have another proposal structure here, and as you can see, other than the description and isActive, we are just using the old values. But for the description and isActive, we are actually updating our proposal so that, as you can see, we can just update the description and isActive, because for the approve, reject, pass, voted and owner, updating this would actually lower the credibility of the proposal. Now that we have our value, we can actually insert it. I'm going to say let result equals p.borrow. We are going to borrow this as mutable since we are going to insert this, and we are going to use this key value pair. And as you can see here, what we have is an option. So we are going to say match result, and we are going to see if there's an error. I'm going to say sum, and we are not going to do anything with this value. And if this is the case, I will say return OK. But if this is not the case, we have none here, and we are going to return an error saying vote error and update error, because this means that actually something went wrong while inserting this and we don't know what. So we are using our more generic error, which is update error. Alright, so this will be our edit proposal function. Let's again check it out what we did here. First, we said that we want to check if we were able to get the proposal or not. For that, we said we are going to have an option here, and we are going to open up this option using match. And if we have some value, then we are going to work with that value. If we got none, then we are going to return no such proposal. And this way, we won't be able to vote for the wrong proposal, or if we don't have it, we can return an error that the front end and the other part of the code or the program can work with. After checking this, next, we looked if the caller of this function is the owner of the proposal, and if we have an error here, we returned access rejected. And after these checks, we just ensured that everything is working fine, and then we moved on with our value, and our value is basically a new proposal, which we edited only the description and is active field. Next, we inserted this new proposal with updated values, and we checked if everything were okay. If it's okay, we return okay. If it's not, then we return update error. It will be the basic ideology for our following functions too. Since this video is getting a little bit long, that will be all for this lesson, and I'm going to see you on the next one where we conclude our smart contract functions. Thank you very much, and see you there. Hi, in our last video, we started our edit proposal function. In this video, we are going to have 2 more functions to create, and then I promise we are going to move on with our Candid file. Now here I'm going to create a new one. We are going to say IC CDK update as we used to. And this function is going to be really similar to the previous one. So I'm going to copy this function here, or let's copy like this and paste it here. Instead of edit proposal, we are going to call it end proposal, and we only need the key. And also we don't need this process too. The beginning of the function is going to be the same. Instead of old proposal, let's call this just proposal. Again, we are doing the same thing. We are retrieving the proposal, but there's a chance that we may not retrieve it. So for this situation, we have a match here. And in this match, we are checking if we were able to get this proposal option here. And if we have some value, then we are going to say our proposal equals to value. But if we got none, then we are going to return no such proposal error. Then we are checking if the owner of the proposal is the one who is calling this function. And if not, we are going to return the access rejected error. Now that we did our checks, we can update our proposal. For this, we are going to say proposal.isActive equals false. It's going to give us an error. Now, of course, we also need to say this proposal.owner, and we are going to update this value in a bit. Okay, now that we made our checks, we are going to say proposal.isActive, and since we are altering the proposal field here, we are going to say let's mute our proposal needs to be mutable so that we can update it here, and we are going to say false. This way we got our proposal and we changed its isActive field to false. That's how we are going to end our proposal. And then we are going to insert this new proposal with the isActive field converted to false. And instead of value here, I'm going to say proposal. And we are going to have a result, which is also an option. So we can have a value in the sum like this. So if that's the case, we don't care what value we have. It means that it was successful. Then we are returning okay. If not, if we got a none, then we are going to return an error saying update error. And this will be our end proposal function, which is again very similar to the one we created above. Above we actually created a proposal and we updated two parts of this proposal and we converted the old ones to the new ones. And here we just changed its isActive field to false. Now we are going to create our last function, which is also going to be an update function. And we are going to call this function both. We are going to have key as the parameter like before. And here we are also going to have a choice. This is a function that we make a choice. All right. Then this is going to return a result. And this result is going to be either okay, or we are going to return an error, which is a vote error. And in this function, we are going to start with the proposal map.width, and we are going to have our p and our curly braces. All right. In this function, what we are going to do again is very, very similar in the beginning. So we are going to say let proposal option equals p dot borrow dot get, and we are going to pass the key here. And this is going to return us an option. So we are going to open up this option like we did in the previous functions. So let's say let's mute proposal, which is going to be a proposal. And here we are going to say match proposal option. If we have some value, then we will say our proposal is equal to the value. If we got none, then we are going to return our error, which is the vote error, no such proposal. Now that we checked if we got the right proposal, now we can work with it. We are going to get our color here. I'm going to say IC CDK color, so we can use later. And next we are going to check if the address that is calling this function has voted for our proposal before. For this, let's say if proposal dot voted dot contains, and this method returns true if the given parameter is in the vector and returns false if not. Let's say color here. And if this is the case, we are going to say return error, and we are going to return vote error, and this will be already voted. And then we are going to say as if that's not the case, but the proposal that is active equals false, then we are also going to return an error, and we are going to say proposal is not active. I think it's a pretty self-explaining error. Okay. Now we check two situations. If the address that called this function is in the voted vector that we had in our proposal, and also we checked if our proposal is active. If the caller of this function can pass these checks, then we are going to move forward with the voting process. For that, I'm going to say match choice. And if we have choice approve, then we are going to say proposal dot approve plus equals 1. So if the choice is approved, then we are going to increment approve. If the choice is reject, we are going to increment reject, and same for the pass. And we are checking this by using choice approve, which we got as a parameter here. So the type of this choice, if you remember that we created this last lesson, we had 3 types in this choice. The first one was approve, second reject, and the third one was a pass. And that's how we are actually getting our input by choosing from one of each option. And we are going to do similar things for the rest. Let's say reject for this one and reject for that one. And finally we have pass here and we have pass here. Now we are going to say proposal dot voted dot push, and we are going to push our caller here. So if they were able to vote with match, then we are going to add this principal to our voted vector. So the next time when they try to vote again, we are going to catch them here where we said if proposal.voted.contains caller. If we didn't have them in the first place after they voted with this line, we are actually adding them to our vector so that the same person cannot vote again. And after this, we are going to say that result equals p dot borrow mute dot insert, and we are going to insert our key and value. And after this, we are going to check if we got none or some result. And this is going to be the same as the one before. We are going to say some, and if that's the case, we are going to return okay. But if this is not the case, then we are going to return an error. And the type of our error will be vote error, and we are going to say update error because we don't know what went wrong, but we just couldn't update the state. And now this will be all of our contract. So let's see what we did here. And instead of value, sorry, we should say proposal. Okay, now we are okay. Again, let's check what we did today. First, created a function called endProposal. And this was very similar to the one before, but what we did is we got the proposal and we checked if we were able to get the proposal. And then we checked if the caller of this function is the owner of the proposal. If not, then we return the access rejected error. But if they passed our checks, then we said that we are going to make this proposal inactive. So we made is active false. And then we updated our proposal in our stable v3. Then we checked if we were able to, if we actually did update our state, our data on the chain. And if we didn't have any problem, we returned okay. And if we had some problem, we returned update error. So with the vote function, we did the first check as we did before. We got the proposal and we checked if we actually got the proposal or we got none. If we got the proposal, then we got the caller here so that we can use later. And we checked if the address has already voted. If they voted, they would be in our voted vector in this proposal. So we checked that here. And then we check if the proposal is active because they cannot vote on an inactive proposal. And if this is the case, then we said proposal is not active. And then we had our match statement. And in this match statement, we looked for 3 possible cases. In the first case, if we got the approve, we incremented approve. And if we got the reject, we increment reject. And the same thing for the pass. And then after this voting process, we added the caller of this function to our voted vector so that they cannot vote again. And finally, we inserted this new version to our stable v3. Then we check if we actually were able to do what we intended with this line here. And if we have some error, we return it. If not, we return okay. So as you can see in our functions, we have similar structures. What we do is we get the proposal, we check if there was an error, and we check additionally if needed, like if the caller is the owner or if the caller has voted. After these checks, we update the data and we insert back the data to the same place, and we check that if we were able to insert this. So even though we have some differences, the whole idea is the same in general. And this concludes our smart contract. So again, these were our functions and we had our state in the beginning. We are also going to delete this invalid choices because we have 2 different choices here and we are checking with 3 possible choices. If our choice is not one of them, then it cannot be not one of them since we are using an enum and there is only 3 possible variants. That's why we are using an enum. In our next video, we are going to create a Candid file for the smart contract because we know how this contract works and you know how this contract works. The computer knows how this contract works. But the problem is our front end still does not know how this contract works. And with this Candid file, we are going to fix that error. So thank you very much for sticking with me the whole process while we develop this smart contract. And in the next video, we are going to conclude our smart contract with Candid file. So thanks again and see you on the next one. Hi, in our previous video, we concluded our smart contract in the lib.rs file. Now we are going to create our Candid file so that our front end can know what's happening on the backend. For that, I'm going to open this Candid file, and we are not going to use this one. And in this file, first we are going to create our types. We used a couple of structs and enumerations. We are going to define them here so that we can say we are going to use this type as a parameter for our function, and for the return values too, we are going to use the types that we are going to implement right now to our Candid file. Now let's start with our proposal. I'm going to say type proposal equals, and here we are going to say record. For the struct we will say record, and for the enums we are going to say variant. And in our proposal, as you remember, we have description, which is string in our Rust, but in the Candid file we call it text. Next we have approve, which is U32 again in Rust, but here it's not 32. We have reject, which is the same. Pass. And we also have is active, which is Boolean, same here. We have voted vector, and for the vectors we are saying vec keyword and then what type of vector it is, and it's a principal vector. And finally we have the owner, which is also a principal. So that's our proposal struct that's defined in the Candid file. Let's do the same for our create proposal. And again, we use Candid type in our Rust code, as you can see here. In our structs, we set this Candid type, which allows us to define these types in the Candid file. We were able to do this because we used Candid type with our struct. Now let's say create proposal. And I'm going to say record. And inside this, we have two fields, description, which is going to be text. And then we have is active, which is going to be a Boolean. Now let's create another type, and this time we are going to create result type, which we have in Rust but we don't have in Candid. And we are going to say result equals, again we set for the enumerations we are using variant, and we are going to have two fields. First we are going to have OK, and then we are going to have the error, and the type of the error will be what error. We have not implemented it yet, but we are going to implement it just after this one. Now, as promised, let's implement vote error. It's going to be variant, and we will have already voted. Proposal is not active. No such proposal. And finally, we have access rejected. We defined this result and we said we have OK and error variance, and for the error the type is vote error, which we didn't define back then, but now after defining vote error you can see that this error is going to be one of these ones. Now let's create our final type, which is the choice. For the choice we have three variants. These are approve, reject, and pass. Now that we have the necessary types, we can create our function signatures. For the functions, we are going to say service, and inside the service, I'm going to start with get proposal. Our get proposal accepts U64. Our functions in general accept U64, which we use as the key in our functions. So we are going to see not 64 as a parameter a lot while defining our function signatures. I'm going to say not 64 here, and as a return type, what we have is an option, and here we can actually use option with opt keyword. I'm going to say proposal, and it's going to be a query function. We talked about this in the previous lessons, but again, we only say query if it's a query function, and if it's an update function, we don't have to indicate that's an update function. Now let's create the next one. I'm going to say get proposal count. It's not going to accept any parameters, and we are going to return not 64 query. Now these were our query functions. Now we are going to create our update functions. Let's start with the create proposal. We have two parameters here, not 64 and create proposal. This create proposal is defined up here. And we are going to return option proposal, and for that we are going to say opt proposal. We didn't say update since we don't have to if it's not query. Now let's do the edit proposal. We are going to accept not 64 and create proposal. We are going to return a result here. Next we have end proposal. For parameters we just have not 64 and we are returning a result. And finally we have our vote, and our parameters are not 64 and choice. We are also returning a result here. Now we created our Candid file. As you can see, it's actually not that hard, but we just need to know a couple of things. First of all, don't forget that we are working with not as a natural number instead of integer types. So if you have U32, that means you have not 32. Instead of string, we have text. And we are defining our structs and enumerations using the keyword type. And if it's a struct, then it's a record. And if it's an enumeration, then we call it a variant. And after we have the necessary types implemented, we can create our functions. We had to implement these types before defining signatures for our functions, because if we haven't defined them, we couldn't use these kind of structures since they are not implemented. And in many situations, we are using custom types like we did with the proposal. So that's all for this video. Now that we have everything in place, in our next video, we are going to test our contract. So thank you very much for this one, and I will see you on the next video. Hi everyone, in our last video, we concluded our smart contract and we edit our Candid file. And in this video, we are going to test our smart contract. For that, I'm going to say dfx start background, and after we start the FX server, then we are going to deploy our contract. I'm going to say dfx deploy. It can take a couple of seconds. Now that our contract has deployed, let's check it out. Now we have our functions here. We have a UI that we can work with our functions. So let's quickly check if everything is working as we expected. First, I'm going to create a proposal. I'm going to say this is the first proposal, and let's say first proposal here, and I'm going to say yes, this is active. It created the proposal for us, and as you can see, we have a null returned, and we said that during our coding, if we don't have anything as a return value, because we said that our functions return the previous proposals when we update it. So here, as you can see, it's returned null because that was the first time we were creating a proposal, so there was nothing to return before this one. Now let's check if the data that we get from this function is what we expected. We have reject 0, and the owner is the principal with this address. The vector of voted people is empty. We have pass and approve as 0. The description is first proposal and is active is true. Everything looks working fine. Now let's try to get the proposal counts. And as you can see, the proposal count is 1. Now let's try to edit the proposal. I'm going to edit the proposal number 2 first, so we can see if the error side of our contract is working as we expected. The description will be first proposal edited, let's say, and is active is going to be true. And I'm going to call this one. It's returned an error with the variant no such proposal, and that's what we expected. And now edit the first proposal, and it's returned okay. So let's check it out if it really worked. I'm going to say get proposal for the first one. As we can see, now the name is first proposal edited. Now let's try to vote on our proposal. I'm going to say the number 1 for our proposal, and we are going to choose between these three options. That's why we said that we cannot send anything other than these three options, so we don't need to check for the other variations in this case. So I'm going to say pass for this one. I'm going to call the function. And the variant is okay. Let's get the proposal and see. Reject 0, and as you can see, the pass is 1. If I try to vote again, let's try to approve. It says already voted, and again, that's what we expected. And for the next trial, let's say end proposal, I'm going to say let's end the first one. It got okay, and once we try to say get proposal, what we are going to have is active false. And now let's create another proposal. Let's call the second proposal, and I want to test get proposal count, and now it's 2. And if we try to get the second proposal, and it's another proposal with the second proposal description. As we can see, our backend working fine. So now it's time to create our front end and test our decentralized application with its front end and with its entirety. Thank you very much for sticking with me all the time while we are creating this proposal smart contract example. And I will see you on the next video where we start coding and working with our front end. Thank you very much and see you there. Hi everyone. In our last video, we finished our smart contract and we said that we are going to move on with the front end. Before moving on with front end code, we are going to look at what we'll be building, actually what we have built, because it's important to note that in this part of the course, our focus will be on how we are going to connect our backend to our front end. We are not going to create our front end from ground up, but instead I'm going to show you how we implemented our backend to the already created front end, so you can know how to connect your backend to your own front end. Okay, so that's what's heading towards us. I already created a couple of proposals here. I have the first proposal, second proposal, and the third proposal. Let's create another one. I'm going to say fourth proposal. I know I'm very imaginative. Fourth proposal. And I'm going to say send proposal. Now, as you can see, we got our fourth proposal and our 3 proposals are here. Now I'm going to edit this proposal. Instead of fourth proposal, let's say proposal X, which is a better name for a proposal in my opinion. And now if I refresh my page, as you can see, our proposal has updated. If I want to vote something on it, I can say vote. And if I try to vote again, it's not going to work because the same person cannot vote twice. And if I want to end the proposal, I click on end proposal. And now the proposal is inactive and we cannot vote. So this is a basic front end, but a very good looking, but a very basic front end that can demonstrate the functionality of our contract. If you remember on the edit side, we were able to edit the description and the activity of it, if it's active or inactive. So these will be the fields that we will be editing. And other than that, we have the basic creating functionality and also the voting functionality. So before further ado, let's move on with our code. Welcome everyone to our last video. In the previous video, I showed you our front end, and in this video, we are going to look how its code works. Again, the aim of this lesson is to provide you the knowledge of how we can connect our backend to our front end, or how we can use our backend, our smart contract in the front end. So we are not going to explain how the front end works, but where we are going to focus is that how we are actually interacting with the backend, since explaining and teaching front end would be very, very long and out of scope in this lesson. Alright, so let's look at our firstly main page. Here I also opened our final project backend.dit file, because our front end knows how to operate with the functions and the structures in our backend through this file, and I thought that it's only fair we do the same. So here we have our main page. The main page is the page that we saw in the previous lesson. So actually, to import our backend, what we need to do is we just need to import our final project backend from declarations, and under the declarations we have final project backend. You can find it here. And this is created when we deploy our project. So as you can see, we don't need to do any additional things, and it's even easier to connect our backend to our front end than the Web 2 applications. Now, after having this file here, we can interact with our backend. And for the first interaction, let's look at this function. In this function, we are having a parameter count, and the name of the function is getCurrentProposal. Inside this function, we are calling our final project backend.getProposal. We are using await and async here because with this asynchronous functions, we are actually waiting for this to be complete before moving on to next. So in our every call in the front end, we are going to use asynchronous functions when we want to interact with our backend. So again, our function is asynchronous, and that's why we are saying await here. And as you can see, we are calling our final project backend, and from our backend, we are calling the getProposal function like any other function that you would call. And let's see what it takes on the right side. GetProposal takes a NOT64, which is U64 in Rust and number in JavaScript, and it returns a proposal. Here we are providing the count, which is the parameter here, and we are saying it's a number because that's the equivalent of NOT64 in JavaScript. And then we are setting current proposal to our response that we got from this function, which should be a proposal. And since the return type is proposal here, if you look at our proposal object, what we would have is a JavaScript object like this. Again, our description is going to be a string, and these are going to be numbers. This is going to stay as Boolean, and it goes like this. Also, the principals will be strings. Now, let's look at this use effect because we are providing counts here, and we are getting this count in this use effect. To get the count, we are actually doing the same thing. We are creating a variable called proposal count, and then we are calling getProposalCount function from our backend like any other function that you would use. You can imagine this as an object that we have in another file, and we are just using its methods. Here, if we look at getProposalCount, then we can see that it doesn't take any parameters and it returns a number. And here, after it returns the number to our proposal count, we are setting our proposal count with this return value that we got. Now, in this use effect, we are also checking if we have the proposal count, and if we have it, then we are calling getCurrentProposal with the proposal count. We are calling getCurrentProposal, the function we defined up here, with the parameter proposal count, which we got from this use effect. Since we got it from here, we are providing the proposal count so that the parameter here on the getCurrentProposal is satisfied, so our function can work. And below it, we also have a list, because if you remember, we have a function to get proposal, but we are not getting the totality of the proposals. For this reason, we have a for loop here, and this for loop makes a call to the backend, and we are getting proposal one by one, and we are pushing them, and we are setting this list as a state up here. Now that we have the necessary arrangement, we got our proposals, we got our proposal count, and we got the most recent proposal to show on the screen. We have the section for styling, and in the section you see we have the hero section. Let's look at the hero section, and we have the proposal card in the hero section. And as you can see, we are passing proposal count and current proposal as parameters here, proposal count and current proposal, so that we would have them here, and we are also passing them from here to proposal card. So basically our proposal count and our current proposal are coming from this main page with the functions that we worked with here. So again, we got our values from here, we passed them to the hero section. In the hero section, we passed them to the proposal card. Now let's check out the proposal card. Again, this part is styling, so I'm not getting to the JavaScript part, but because what we want to do is we want to understand how we can work with the backend. And from what we talked already, I think it's very clear that what we only do is that we just import the backend, and then we use them as we would normally use other functions. The only difference that we need to pay attention is that we need to use asynchronous functioning with these methods, because since there's a call on the backend, it can take time, so we just want to wait for it. But it's a pretty standard way to do things on the backend if you are working with an API or if you are working with this kind of structures. And in this part, as you can see, we are calculating the total votes. And to calculate the total votes, we are checking if we got the proposal. And if we got the proposal, we are checking if we have the first element of the proposal, and if we have the approve in it. The proposal 0 is going to give us a proposal here like this, and by calling .approve we are actually calling this approve field of our struct. So if we had a JavaScript object, we would have used this the same way. So again, there is nothing different going on here. And if you look at this handle vote part, this is the part where we handle our vote request. So what we have is we have a user choice variable, and we are going to set this user choice variable based on the instruction we got. On our front end, if we got 1, then we set our user choice to approve null. We are saying approve null here because in our backend, when we make the call, we can see from this choice what we have is we have approve, reject, and pass. And these were enums from our Rust code. And these enums doesn't carry any value. Since they don't carry any value, we are going to send them with null. But if we were carrying some value like a string or U32 or any other kind, then we would add them here. Let's say our choice was 3. In this if else statement, we moved on from here. Since it's not 1, we moved on here, it's not 2. Then for the else clause, what we have is user choice. And for the pass, we have the null. Because as we said that we are not carrying any value, so that we are passing them with null, but they will still have this pass inside this bracket. So it's going to satisfy what we need. So that's the important part that you need to pay attention when working with our backend, specifically when working with enumerations on our backend and trying to call them from the front end. Next, we have this vote variable, and we are actually making the call like we used to in our previous functions. We are calling our final project backend, and we are calling the vote function. And if we look at the vote function, what we need is not64 and choice. As in not64, we are providing proposal count, which we got from here, and also we got from here. So it comes from here to our hero section, from our hero section to our proposal card. In our proposal card, we are using this to vote on some proposal. Then we have our user choice, which we set during this if else statements. As we talked, we provided null since we are not carrying any value here. We just have the basic enumeration functionality. And that's actually how we work with our backend through our frontend. Now let's look at a couple more examples. We have our handle and proposal, and this works as the same way as the ones before. What we are doing is we are calling our backend, and we are calling and proposal, and we are just providing the proposal count as the parameter here. And for our checks, if you remember, we had a couple of checks on our and proposal side. First, we checked if the proposal exists. Then we check if the owner of this proposal is the one who is calling this function. Since we are making these checks on our backend, we don't have to do them on the front end. And that's the basic ideology. We want our backend to do the whole thing, and we want our front end just to communicate and be the actually UI for the user input. And finally, for the edit proposal, what we are doing is pretty straightforward. Like before, we are calling our function with the await keyword. Then we are calling edit proposal from the final project backend, and we are providing proposal count. So let's check what we need for the edit proposal. We need a not64 and create proposal. Not64 is actually U64 and in Rust and number in JavaScript, as we said before. So we are going to just provide proposal count, which is a number in JavaScript, and it's going to satisfy our need. And then we have the create proposal. And for the create proposal, we are creating a JavaScript object with the same fields we have on the right side. The right side, I mean here. Once we look at it, we have description and is active. So we put description and is active. And description is waiting for a text. So we are providing a string here, edit input string. We are providing is active field from our proposal. So we can just carry the same value for the new one. And we have a console log saying edit. Of course, our frontend have a couple more functionalities, but it's just the same thing. If you look at the idea here, what we are doing is we are importing our backend to our frontend at the top. And after that point, we can use these functions just we would use any other function. 3 things to be cautious about. And the first one is that, again, the types of the variables are different. Here, text meaning string in JavaScript, and the different types like not meaning number in JavaScript. So we need to look for that one. And also we need to remember that we need to use asynchronous functioning and await keyword for our function calls on the front end. And finally, it's important that we have the structures here so that we would have the same on the front end. So as we saw here, while we are making a call, we are actually calling our backend with the object that we created in front end, which is the exact same thing when it's converted to Rust or the did file. So we use the same name of the field and also the same type, but we converted it to JavaScript. Other than that, it's important to remember we are sending them with null if we are working with enumerations on the backend, but that's because we don't carry any value. If we carried any value with this variance inside of our enumeration, like a string or U32, then we would update it accordingly, saying some string if we had it here. But since we don't have this functionality, we just have null. All right, so that's how we can create our backend and smart contracts on ICP, and that's how we can connect them to the front end. In my opinion, if you know how to create front ends, then it's not an additional work to get to know how we can work with our backend in the front end, because it's so simple that it's actually easier than the Web 2 version. So the important part is to create our smart contract on the backend and make the necessary checks on the backend so that the front end doesn't responsible of making the necessary checks, because remember, anyone can send transactions to our contract, not just from our front end. So it's important that we need to cover our security basics on our backend. And that's all for our Internet Computer Protocol course. Thank you very much for sticking with me the whole process of the development of smart contract and also connecting them to the front end. And I wish you luck on your journey to become a smart contract developer. Thank you very much and happy coding.